In this video, I would like to talk about dependency injection. So dependency injection is a term that you hear quite often when you work with an object-oriented programming language. One definition of dependency injection is that it is basically providing the objects that an object needs, its dependencies, instead of having it construct them itself. It's a very useful technique for testing since it allows dependencies to be mocked or stubbed out. It could be worth mentioning that dependency injection is quite closely related to the dependency inversion principle. This is one of the solid principles, so it's the D of solid. And the general idea of this is that high-level modules which provide complex logic should be easily reusable and unaffected by changes in low-level modules, which provide utility features. To achieve that, you need to introduce an abstraction that decouples the high-level and low-level modules from each other. So high-level modules should not depend on low-level modules, which is quite close to what the author mentioned here. Both should depend on abstractions. And also the second one is that abstractions should not depend on details. Details should depend on abstractions. So a good way to try to understand dependency injection and why it's useful is by looking at a code example. So here I have a class which I call application, and it has this member field called storage. In the constructor, I'm creating an instance, the in-memory storage, and I'm storing it on the field. So this is a simple implementation of how to store something in memory. So it's not persisting anything to the database or in a file, it's just storing it in memory. And if I create this application as simple as saying new application, one can wonder, why is this potentially a problem? Why is it an issue that we instantiate this storage class inside of the constructor? One problem could be that if you want to test this class, so you want to create unit tests for this class, then you can't really test this in isolation because you are forced, or you have no choice but to instantiate this instance as well. That means that per definition, you won't be able to test it, and you can't test the logic that is application specific. You have to deal with the storage functionality that comes with it. Another thing that is problematic with this approach is that if we want to replace the storage mechanism in the future, let's say that we want to store things in a database in the future, then if we have made a tight coupling between the application class and the in-memory storage class, then that would mean that we would have to make a lot of changes inside of this application class whenever we want to replace this part of the system. So let's look at an example of how we can achieve a better software design with dependency injection. Here, what I'm doing is I will create an interface. So I will say that we have this storage interface and it has two public methods. So we want to make sure that any storage mechanism will implement this interface, and we also want to inject that storage instance inside of this application. It's basically a storage instance which is implementing this interface. Right now, the application doesn't care what storage mechanism that it's using. It just wants to know that there will be a storage instance that it's using. So it is not interested in what type of storage mechanism that is being used. And then this class has to implement the storage interface. I will rename this to data storage. And now we see that I'm implementing this interface. I'm still able to use the storage mechanism in the application if I want. So let's try to inject this dependency now. So I will create an application instance, and we can see that it's expecting a storage instance. So let me provide that. So I will say that the storage instance will be an in-memory storage, and I will pass that or inject this dependency to the application this way. What's good about this approach is that in the future, if I want to change this to a database storage, for instance, so I will implement the data storage interface. It's not the best naming here, and I will implement these methods like this. So just imagine that this has lots of logic for connecting to a database and doing database specific stuff. And then the only thing I had to do is change this instance to database storage. And I didn't have to make any change inside of the class application. The application class still works as before, and no change had to be made inside of this class. So I basically just swapped the instance, and I didn't have to make any change to the application class. This is a huge benefit of using dependency injection. So hopefully you understand why dependency injection is important. To sum this up, I think it's important to look at how the old design was. So I had this application class, and it had an association to the in-memory storage. In other words, we can say that the application, which is a detail, is depending on another detail. And this violates the principle of dependency inversion. So we don't want high-level modules like an application, which has a bunch of complex logic, to depend on a low-level detail or module, which provides some type of utility, in this case, storage, because this means that we can't easily replace this utility in the future. Also, we can't test the application in isolation, and so on. A better design is to follow the dependency inversion principle. And if we just look at the diagram, we can see that actually there is an inversion made. So the dependency, which was pointing between the application in memory storage, is inverted. So now this arrow, this class has an arrow which points in the other direction. So we have inverted this dependency. So instead, the high-level module should depend on an abstraction, which is an interface, and the low-level module should also depend on an abstraction, which is an interface. So this way, we can easily swap this without affecting this. So this is, in short, what dependency inversion is about and how you can achieve that through dependency injection. Thanks for watching, and I'll see you in the next one.